Hey guys, just back with another coding video. This is C programming. We're going to go over bitwise operators in C. So sometimes you may need to know how to do these math calculations with the code. So unfortunately there is some math with this. So you have to convert the numbers to binary. It's not that hard, so I've already started this. So what's happening here is so this is a code here. We have A pointing to 3, B pointing to 22. I've taken 3 and converted it to binary. So how you do that is you take the decimal, this is one way to do it, it's probably the easiest way. You divide it by 2, you get the quotient, I think that's what it's called, and then the remainder. So you go 3 divided by 2, that's 2, so in computer division, at least in C division, it takes, the way it divides is it just goes, okay, well it goes in once and has a remainder of 1, so you don't have a decimal here, unless you use doubles, I guess. So we go 1, remainder 1, then we carry the 1 down like this, from here to here. Then we go 1 divided by, we continue to divide it by 2, so we go 1 divided by 2. 1 divided by 2 is 0, remainder 1, because there's 1 left, it wasn't divisible. And then we carry the 0 down here, and that's the last one. So if you get a 0, that's the last one, because 0 can't be divided by 2. So the answer to this is, so the way you write 3 in binary is 1, 1. So you take it from the bottom to the top. So you write it like, you write this digit first, 1, here, and then you write the second digit like this. So I think the bottom is the least significant bit and the top, the bottom is the most significant bit and the top is the least significant bit, I think. Might want to double check that, but just do it like that. Either way, just do it bottom to top. So basically so after that we put, so when we deal with bits, they either have to be in 4 bits or 8 bits. So that's why I added 2 zeros to the end. So the binary of 3 in a 4-bit representation is this number right here. And the way to convert it back is, actually we'll do that in a sec. So these are the bitwise operators. So once you know how to convert to binary, that's pretty much all you have to do, and then we'll do of how to convert the binary back to the base 10 decimal. A normal number is base 10, which is a decimal, and a binary number is a base 2. Octal is a base 8, I believe, and hex is base 16. Hexadecimal is base 16. I'll think about doing a video on all the conversions for you guys. Maybe not, we'll see. But at this time, we'll just go over bitwise operators in this video. So we have bitwise AND. Don't get these confused with the logical operators, by the way. So it's not 2 ANDs, it's just 1 AND, 1 AND %. So if it's 2 AND %, then it's a logical operator, but in this case it's bitwise because it's just 1. So we have bitwise AND here, bitwise OR, just 1 again. It's just all going to be just 1 except for the left and right shift. So I guess it's just unary. So we have bitwise AND, bitwise OR, bitwise XOR. That's symbolized by, I don't know what that is, but it's shift 6. What it's called, it's like the hat symbol. It's like the power of, there must be some kind of name for it. But it's like when you do the power of with computers, and that's how you do it. And then we have the tilde operator, I think that's what it's called. That's the bitwise not. So it's just like the exclamation for a logical not. Looks like the waves coffee symbol. Easy way to remember bitwise not is like it's waves coffee. If you guys know what Waves Coffee is, I don't know if they have that in the States, but it's in Canada. So we have Bitwise left shift going left, and then Bitwise right shift going right. So left shift, the way it goes is that it's the way the arrow points. So the pointy part's to the left, so it goes left. Here's the pointy part goes to the right, so it goes right. So that's just the way I remember it. So we got less than is left shift and greater than is right shift. So also less than has an L here. It's like less than for left shift, and then greater than would be the other one for right shift. Okay, so how do we do the bitwise what's it called? Bitwise not. So the way to do bitwise not is a little confusing. It's not like your standard 2's complement, if you guys know what that is. So I believe the formula is negative n plus 1. So the formula for this is negative n plus 1. So we negate whatever n plus 1 is. So in this case, they want printf a and b. So we already did that. It just prints out a and b, and then here printf. So this is a string here, a points to %d. The format specifier is going to go in order. So this %d is going to take the first one outside the quotes or the string. So this is a string here. A equals %d. So the first %d is going to correspond with the first variable outside before the first comma, and the second one it's going to scan, the compiler is going to scan for the next the next format specifier. So it's going to get this one %d, and that's going to correspond with the next variable after the next comma. So they go in order like that, if that makes sense. So you take the first one for the first one, and then second one for the second variable here. So hopefully that makes sense. So here we have a string a equals %d, so it's just going to print a, and then tab is going to space it out. Then it's going to ask for, so this is just a string here, tilde a equals %d, so then it's going to get the corresponding value for tilde or bitwise not a, pretty much. So how do we figure that out? So we already have 3 converted here, so we'll have to do 22 in a sec. So what we're going to have to do is we're going to have to take this number, add 1 to it, so I'll just do it under here, I guess. So I'll just say bitwise not 3 equals to go with binary 0011, we add 1, right? So how do we do binary addition? I guess we're going to have to know how to do that. I'm going to have to tell you guys. So what we're going to have to do is just remember the rule when we add 2 ones. I guess I'll just do this up here. Actually, I'll do it here. So we have no, that's wrong, sorry. Binary addition rules. You just have to remember 2 ones equals 0 carry a 1. And 3 ones equals 1 carry a 1. That's it. For subtracting, it's when you subtract binary. I don't think we'll be doing it in this video. I might do a video on it, but we have to, when you borrow, the 0 becomes a 2. Okay, so when you borrow, when you borrow from a 1, it becomes a 2. So we'll go over that later. Try to do that in another video. So here we have a 1 plus 1. I'll just do like that. Like we're adding this. Okay, so we have 1 plus 1, that's going to be a 0, carry a 1, so I'll just make another row here, and I'll just say, just call it carries. These are like carrying, like if we were carrying something, so 1 plus 1 here is going to be a 0, carry the 1, right? So those are carries up here. Okay, so 1 plus 1, 0, carry a 1. 1 plus 1 is 0, carry a 1. 1 plus 0 is 1. And 0 just carries, just goes down to 0. Just carry the 0 down. Okay, so now we have this number here. So to convert, we'll just say convert binary to decimal number base 10. What we have to do is we take, so we start from the right, so the value is going to be 2 to the power of 0 below this 0. To the left we keep adding 1 to the power, so it goes on to however numbers you have, however many numbers you have. So this is really going to be, I'll just space it out like this. Might be too much space, but that's okay. So down here we're going to have 2 to the power of 0 plus, this one's going to be 2 to the power of 1. Then we have a plus here, and then 2 to the power of 2. And it keeps going on, however many numbers you have like that. And then 2 to the power of 3. So that got a little spaced out. Okay, so we have 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2. So I'll just start again, sorry. So we have 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3. So there's another step we have to add. We have to multiply it by the 0. So I'm going to go back right, I'm going to go right to left again. Like I'm going to go this way, but write it out the other way. So I'm going to go, so it's 0 times, I'll do it with the decimal. Actually I can use the x, but decimal or x. Because sometimes in notation you'll see a decimal. Our professor did that and kind of confused us in our notes. So we had, he was trying to explain the logic gates, but they use a 0. Sorry, they use a decimal for the multiplication. So maybe I'll just do that here. So we have 0 times, so the decimal means multiplication. So maybe I'll just do it like this instead. Actually, no, that's confusing. So we have, I'll just do it in decimals. Hopefully people who don't understand English will understand what I'm saying. So maybe I'll just do it, so I'll just say multiply. Or same thing. Same thing, right? Multiply or the multiplication x symbol or just a dot. Sometimes they have that in math as well. So we have 0 times 2 to the power of 0 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 3. So this one is first, 0 times 2 to the power of 0, which is just 2 to the power of 0 is going to be 1, so just remember that. Times a 0 will be a 0. So the next one we have 0 times 2 to the power of 1. So 0 times 2 to the power of 1. So 0 times 2 to the power of 1, so 2 to the power of 1 is going to be 2, times 0 is going to be 0, plus 1 times 2 to the power of 2. So that's going to be 4. Then we're going to have a plus. 0 times 2 to the power of 3. So 2 to the power of 3, 2 times 2 is 4, times 2 is 8, so times 0 is going to be 0. So the answer here is just going to be this one here, which is going to be 4. So the answer is 4. And then the last step, we have to negate it. So the formula here was negative n plus 1, so we have n plus 1, now we negate it. So the answer is negative 4. That's the final answer. So that's the final answer for the not, I believe. So we can just run that to check. So I just set a breakpoint here and then I click the debug icon. So my window's external, but you should see it if you run it. The answer was negative 4. So that was correct. So we have the next one here. Sorry, let me just pull up my notes to see. Okay, so the next one is printf. So we're going to have a printf here. If you can hear anything in the background, that's just a binaural beat going on. I usually have them when I code, so I just kind of helps your brain learn better. So we have printf here. Not A points two. We're gonna have A and B, or A and B like that as a string, and we'll say %d, A and B %d, new line. Probably just need it like that. A and B %d, new line. Actually, they have it spaced out, so let's do it like that. And then we'll have here A and B like that. So A and B, we're gonna need a. I just made a video on this, I believe, for the logic gates. Or yeah, so at least some of the Boolean gates, most of them at least. Not the whole circuit stuff, but just at least some of the. I think we did the truth tables. I'm not sure if I'll do the circuits, but anyways, if you guys have seen that video, this should be in the playlist. If you haven't seen it, it should be before this video, hopefully, or somewhere around this video. I think I called it truth tables or something, Boolean truth tables. So what we're gonna have here is, I guess I'll probably have to do that again, so I'll do a quick version of it. So I'll just do it here. Actually, okay, I'll just do it here. So we have, it's gonna be the same thing as a normal logical AND, pretty much. So remember, for that we're gonna have an A, then a B, then an A and B. And remember, true is 1. True is either any other number than 0 pretty much, so it's usually 1. So true corresponds to 1 and false corresponds to 0. In circuits, true can be 5 volts, 0 can be 0 volts, it can be 5 volts, or maybe any other volts other than 0, or I think it's usually 5, but I'm not a electrical engineer student, but I'm a computer science student, so we don't really see too many circuits and stuff like that. We just have like one class on it. So anyways, we have this. So I'm gonna fill in all the blocks here. I hated physics anyways. I actually was in engineering, but I dropped out because I hated the math and the physics. Coding was way. I'm glad I got into coding because it was way better than that. Okay, so anyways, we have A. So if A is false and B is true, and then so A and B is gonna be A and B is gonna be false, because for an AND both have to be true. So either 0 has to be so both of them have to be true in order to be true. So if we have A is true and B is false, then A and B is going to be false as well, or 0. So if we have A is A is false or 0, B is false or 0, then A and B is false or 0. If we have A is true or 1, B is true or 1, then A and B is going to be true or 1. So that's the only condition where it's going to be true, I believe. I'm just going to double check that on my notes, just so I don't send you guys in the wrong direction. I have a picture here that I drew somewhere. And yeah, so there's only one possible true, and that's where both ones have to be true, so that's correct. Just to double check for you guys. So we have, okay, so what's going to happen now? So we're going to need 22 as binary. Okay, yeah, I think that's what's gonna happen here. So sorry, I haven't done this in a little bit. So we have okay, so we're gonna have to convert 22 to binary, so let's just go down here. So I haven't done this one yet, so I'll do it with you guys. So we have 22. We're gonna have to take 22 divided by 2. That equals to 11 remainder 1. Then we carry the 11 down, so we have 11 divided by 2 equals 5, because it goes 5 times remainder 1. And this is computer division, so it's not, there's going to be no decimal, like for a whole number, for an integer. If you have doubles, it'll convert that to a decimal. So we have 5 here divided by 2. So that equals, goes in twice, remainder 1. So then we go 2, we carry the 2 down, so we go 2 divided by 2 equals to 1, remainder 0. And we carry the 0 down. That's the last one, so when you get 0, that's going to be the end. So 22 should be, am I missing a digit here? I think, did I mess that up? Yeah, I did. Apologize. We still have to carry that 2 down. So don't get confused on this part. So so we got, sorry to confuse anyone, so we have 2 divided by 2, that's 1. And since we have a 1 here, it's not a 0, we have to carry it down, so don't forget that. We stop only when it's a 0, not when it's a 1, so here we have, since it's a 1, we have to carry it down. That equals 1 divided by 2 is 0, because you can't divide that, you can't divide 2 into 1, right? You can't divide 1 by 2. So that's remainder 1. And then, so that's just going to be, the last one is going to be 0. That's where we stop here, is when you get 0. Anything divided by itself is going to be 1. You have to carry that quotient down, then divide it by 2 again to get 0. So you don't stop until you get 0. You can double check by Googling this if you want, which I will do right now actually. So the answer is 1011. Actually, I messed it up as well here. So apologize. So 22 divided by 2, that's goes in exactly, so it should be 22 divided by 2 is 11, remainder 0. So I apologize. Hopefully I'm not confusing anyone. So maybe I should just run through this again one more time so I don't confuse anybody. So we have 22 divided by 2. That goes, 11 goes into 20, sorry, yeah. So 2 goes into 22 evenly 11 times. That gives us 11. So 2 times 11 is 22. Gives us a remainder of 0 because it goes in perfectly. Next one we carry the quotient 11 down. 11 divided by 2. We get 5. So 2 times 5 is 10. We have a remainder of 1. The 5 quotient gets carried down. 5 divided by 2. That's 2 goes into 5 twice. 2 times 2 is 4. We have a remainder of 1. We carry the 2 down. Then we have 2 goes into, so 2 divided by 2 goes in evenly again once. 2 times 1 is 2, so there's no remainder. We carry the 1 down here. Then we have 1 divided by 2. That equals 0 because 1 cannot be divided by 2. There's a remainder of 1. Excuse me, so the 0 gets carried down. And we finish here. Then we write we take them from the bottom to the top. So we go, first we write this one, 1, then this one, then we go up from there. So 0, then this one, 1, then this one, 1, this one, 0. So I believe this is the most significant bit, and this is the least significant bit, I think. I'll just say least sig bit. And just say most sig bit. Okay, so that's our answer. Here we have 5 digits, so we'll add 3 to make it an 8-bit representation because we obviously can't make it a 4-bit representation here because it already has 1 extra. So we'll just say final binary of 22 base 10 equals to 0, 0, 0, 1, 0, 1, 1, 0. I think that's correct. 1, 1, 0. I won't space it out. So 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 1, 0. We added 3 to make it an 8-bit representation like that. Okay, so now what we have to do to get the AND, the bitwise AND, is we have to take the 2 binary numbers, we put them on top of each other, then we take the logic, we turn it into basically a Boolean truth table like this. So what we're gonna have to do is take this 4-bit binary, convert it to an 8-bit by adding 4 zeros, stack them on top of each other, and then do the AND truth table pretty much. So I guess I'll just do that up here. Actually, no, it doesn't really matter where we do it, but I should have just. This is kind of getting all jumbled here. So we have. What is this here? So yeah, that's our 2 binaries here. That's fine actually. So we have our 2 binaries. So let's just go here. So this is our AND. This is our second number, this is our first number, so that's okay. And we're gonna have to say we want no not here, we're done with that. So we'll just say binary of 3 is this. We'll just say it's a 4-bit representation, and then we'll say we want an 8-bit. So we'll add 4 zeros. Those will look right. 1, 2, 3, 4. Space it out 0, 0, 1, 1. So we'll just say it's a 8-bit representation. Binary representation. Okay, so then now when we want, let's say we want and what was the question? A and B. So we want A and B here. We want binary AND. So we're gonna have to stack the binaries on top of each other. I don't think it matters which one you do on top, to be honest. So here we'll take 0. We'll take the smallest one first. So we'll take the binary 3. 1, 2, 1, 1 like that. Then we'll take the second one. 0, 0, 0, 1, 0, 1, 1, 0. Okay. So now we're gonna take our truth table here. Except we have more options here. So we're gonna check for the truth table conditions. So if we have a 1 and a 0, that's a true and a false. For an AND, remember the rule is both have to be true. Okay, so here's, if you just look ahead, we can see there's only going to be one true here. So we're going to have a 1 and a 0, so a true and a false, that's going to give us a false for an AND. A 1 and a 1, so a true and a true is going to give us a true. A false and a true is going to give us a false, 0. A false and a false is going to give us a 0 or false. A false and a true is going to give us a 0 or a false. A false and a false is going to give us a 0 or a false. A false and a false is going to give us a 0 or a false. And a false and a false is going to give us a 0 or a false. So that's our binary AND right here. Last step, we have to convert it back to base 10. Back to base 10. Base 10 representation, or just a normal decimal number. Right? So that's what we're gonna have to do here. So we're just gonna have to take this, space it out again, so 6 zeros I think, and a 1 and a 0. So I'm just gonna skip most of this. We're not gonna have to do the whole thing, but so here we're gonna have 2 to the power of 0. Remember we just did this for the naught, so here we're gonna have a 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2, and then so on. Which we're not going to need all those because they're just zeros, right? So don't need to do all those. We don't really even need to do this one here. I'm just showing you guys just in case you guys forgot. Actually, maybe I actually don't really need to do it. So just remember, if there was ones here, we would go 2 to the power of 3, then here 2 to the power of 4, then here plus 2 to the power of 5, then here plus 2 to the power of 6, and then here plus 2 to the power of 7. But here we just have a 0, so we really don't even need this one. So what we're going to have here is we're going to take this one here, this one, so 0 times. So 0 times 2 to the power of 0 plus 1 times 2 to the power of 1. That's going to give us 0. So 0 times 2 to the power of 0 is going to be a 0, plus 1 times 2 to the power of 1 is just going to be 2. So the answer should be 2. So we should say A and B equals 2, should be 2. So hopefully that's correct, so we'll just check here. Just save and debug that again. Yeah, so these bitwise operations can take a long time. They're kind of annoying too because there's a lot of math involved. So yeah, the answer was 2, so that's good. How many more do we have left? So we have the conversions ready at least. So we got two more and 3 shifts. Okay, so a little bit more to go here, so we'll just try to speed it up. So we have printf. The next one we're gonna have a. So we're gonna say A or B, bitwise A or B. We're gonna have %d modifier, a %d modifier here. We're gonna have a new line. Let's have a new line here, and then we're gonna have end of the string, and we'll say we're gonna call A or B. We're gonna pass that into the format specifier. So remember that format specifier is gonna correspond with that variable here, or these variables, or this math conversion. So what we're going to do here is we're going to stop debugging. Okay, that already stopped. So here, so we're going to take, so we're going to need another truth table here. So we'll have A, B, A or B. So in this case, if 1 is true, then it's going to be true, I believe. So if we have 0 for false, we have A equals 0 or false, B is 1 or true, then A and B is going to be true in this case. So if we have A is true and B is false, or so A is 1 or true, B is false or 0, then A and B is going to be true or 1. If we have A is false and B is false, or so we have A is false or 0, then B, if B is false or 0, then A or B is going to be false or 0. If we have A is equal to true or 1 and B is equal to true or 1, then A and B is going to equal to true or 1. So that's all. I believe that's, I'll just double check that as well for you guys so we don't, so I don't send you guys in the wrong direction. So we have, yeah, so if 1 is true, then it's going to be true. So that's correct. We should have 3 trues and 1 false. Yeah, so the only one that's going to be false is the one with 2 falses, or 2 zeros. So now all we have to do is just take the binaries here and just, like that. So just to check if that was correct, we have the smaller one on top, I believe, so 0, 0, 0, 0, 0, 1, 1, and then this one was 0, 0, 0, 1, 0, 1, 1, 0. Okay, that's correct. So here we'll just put that here. So here we'll just say A or B bitwise. Excuse me, so we'll have here, so a true and a false, or a 1 and a 0 is going to be true. A true and a true, or a 1 and a 1 is going to be a true or a 1. A false and a true is going to be, or a 0 and a 1 is going to be a true. A false and a false, or a 0 is going to be a false. A false and a true is going to be a true or a 1. False and a false is going to be a false or a 0. False and a false is going to be a false or a 0. False and a false is going to be a false or a 0. So just to check that, we have true, false, true, 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 false, true. So we have a true here, so it's gonna be true. Double true here, gonna be true. True here is gonna be true. False. false. And we're going to have true here is going to be true, false, false, false. Okay, yeah, so 0, the answer is, in binary, it's 0, 0, 0, 1, 0, 1, 1, 1. That's base 2. So then if we want base 10, decimal, we're going to have to do the 2 times 0 plus 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4. Or sorry, 2 to the power. So we'll just do that here. So we already know kind of what's going to happen. So I'll just maybe just kind of skip over that with you guys. So we have 0 times 0 times 2 to the power of 0. Then we're going to have, so we have 0 times 2 to the power of 0 plus, that's wrong, apologize. So let's space that out here. So we have 1 times 2 to the power of 0. So then we have plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 3 plus 1 times 2 to the power of 4. So that should be correct. So we have 1 times 2 to the power of 0 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 3 plus 1 times 2 to the power of 4. So this one's going to get cancelled out because it's just 0. So we have 1 times 2 to the power of 0, that should be 1. Plus 1 times 2 to the power of 1, that should be 2, because 2 to the power of 1 is 2 times 1 should be 2. Plus 1 times 2 to the power of 2, that should be 4. Plus a 0, because 0 times 2 to the power of 3 is 0. Plus 1 times 2 to the power of 4, so 2 times 2 is 2. Sorry, 2 times 2 is 4. Times 2 is 8, times 2 is 16. So this one should be 16. So we have 3, 7, 1 plus 2 is 3, plus 4 is 7, plus 0 is 7, plus 16, 23? I think it's 23, so we could just double check if hopefully it is the right answer. So I'll just check. Yeah, the answer is 23. So good job, guys. You guys are learning. So we have the next one. So we have XOR now, the last one. Oh no, sorry, yeah, this is the last Boolean one. Or that requires a truth table at least, so I guess it is kind of like a Boolean. So we have, so the next one is A XOR B. Then we have 2 shifts, but the shifts won't take long because we already have the conversions done. So we have, I'll just stop that. So here we'll have printf. So we have printf here, and then we'll have A XOR B equals %d modifier, new line, close, so end the string, comma. So A XOR B, we're going to pass that into the format specifier, which is going to, this is format specifier is going to correspond with this. So after that, there is going to be another truth table here. So a bitwise truth table. I think if 1 is false, if 1 is true, it's going to be true, but if both are true, it's going to be false. So it's a little confusing. So I'll just pull up a picture that I have here somewhere. Okay, so we have, so one must be true and one must be false to be true. That's the only condition for it to be true. So one must be 1 and one must be 0 to be true. So one must be 1 to be 1 or true, and one must be 0 to be 1 or true. So that's kind of confusing, so I'll just write it out here. So we have A, B, and then A, X, or B. That's the truth table. So here we have 0, so if A is 0 or false, and B is 0 false, 0 or false, then we have A or B is going to be 0 or false. So if A is 0 or false, and B is 1 or true, then A and B is going, sorry, A, X, or B is going to be 1 or true. So if we have A is equal to 1 or true, and B is equal to 0 or false, then we're going to have A, X, or B is going to be 1 or true. So 1 or true only if it has 1 that is true and 1 that is false. So this one's kind of confusing. So if we have A is 1 or true and B is 1 or true, then it's still going to be 0 or false. So I'll just have here 1 must be true, or 1, and 1 must be false to be true. So 1 must be true or 1 must be false or 0 to be true. So those are the only conditions where it's going to be true. So here we can just take we can just copy that here and we can just paste that down here. We can say we want A, X, or B. So following these conditions, 1 or a 0 is going to be, so a true or a 1, and a false or a 0 is going to be a true or a 1. So a true or a 1 and a true or a true and a 1 and a true and a 1 is going to be, or a true or a 1, and a true or a 1 is going to be a false or a 0. So here, the next one is going to be, so a false or a 0 and a true or a 1 is going to be a true or a 1. A false and a 0 and a false and a 0 is going to be a false and a 0. A false or a 0 and a 1 or a true is going to be a 1 or a true, according to our truth table here. A false or a 0 and a false or a 0 is going to be a 0 or a false. And then a false or a 0 and a false or a 0 is going to be a 0. Hopefully I'm saying that correctly. So a false, next one, so a false or a 0 and a false or a 0 is going to be a false and a 0. So the answer in binary, just to double check, so we have 1 is true, 1 is false, we're going to have a true or a 1. 1 is false, 1 is true and 1 is true, so we're going to have a false or a 0. 1 is false, 1 is true, so we're going to have a 1 or a true. 1 is false, 1 is false, so we're going to have a false or a 0. 1 is false, 1 is true, then we're going to have a true or a 1. And then the rest 3 are false. So that should be the answer. So we're going to say binary AX or B. And lastly, we're going to have to convert that back to base 10. So we're going to have 2 to the power of 1 times 2 to the power of 0 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 3 plus 1 times 2 to the power of 4. That should be correct because this is going to be 1 times 2 to the power of 0 plus we're going to have 0 times 2 to the power of 1. 0 times 2 to the power of 1 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 3 plus 1 times 2 to the power of 4. So 0 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3 plus 2 to the power of 4. Yeah, that should be correct. So we have 2 zeros here. We can just cancel those. So we'll do that here. So we have 1 times 2 to the power of 0. That's going to be 1. 0 times 2 to the power of 1. That's going to be 0. Plus 1 times 2 to the power of 2. So that's going to be 2 times 2 times 1. Or 1 times 2 times 2. So that's going to be 4. Plus 0 times 2 to the power of 3. That's going to be 0. Plus 1 times 2 to the power of 4, so that should be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 1, so 16. So 1 plus 0, which is 1, plus 4 is going to be 5, plus 0 is 5, plus 16 should be 21. So the answer should be 21. So we'll set our breakpoint here and just check that that was correct. There we go, so we have 21 that came up in my output that you guys can't see. And then we just have a few more shifts and we're done here. So 3 more shifts. So the next one's going to be printf a left shift 1. So we'll take, so we'll stop debugging. So here we'll write printf. We'll have the string a left shift 1 equals for a %d modifier, new line, and the string, comma, b, no sorry, a left shift 1. So format specifier corresponds with this whole operation here. So we're gonna have what we're gonna do here is we're gonna take the binary of 3 because it wants a, so a equals 3. So we're gonna take 3 here. We're gonna look for that. We're gonna take the binary number that is. I think this has to be done in 8-bit. I believe. So left shift. Yeah, I think it does have to be done. This has to be done in 8-bit, I believe. So we have to take. So what we're gonna do is we're gonna have. We'll say here is we want a left shift 1. Is it 1 or 2? Oh, sorry, we want an a left shift 1. A left shift 1. So that's our binary 8-bit representation of 3. We're gonna take this place and move it over 1. So we kind of take it from however many bits we want to shift it. I don't know what the max number is, but I've only been asked between up to 8 bits. So basically, if you want 2 bits, you start here and move this one here. You move everything over 2 bits to the left. If you want 3 bits, you start here. You move everything 3 bits to the left. So here we want 1 bit. We want to shift 1 to the left, so we start at not the first 0, but the second 0. So we start at the second 0, and here we're going to go. This 0 is going to move here, and everything's going to shift over by 1. So this whole number is just going to be the first, you can just think of it that this binary number is going to be the same number minus the first 0. So that's what I'm going to do here. So I'm going to go 0, 0, 0, 0, 0, 1, 1. That should give us 7 digits, whereas here we had 8. Then I'm going to add 1 0 to the end. So the answer is 0, 0, 0, 0, 0, 1, 1, 0 in binary. Then we convert it back to base 10. So we're going to have 2 to the power of 0 plus, so 0 times 2 to the power of 0 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 2. So we'll just kind of try to do a quick version of that. So here we'll have 1 times 2 to the power of 1 plus 1 times 2 to the power of 2. So 1 times 2 to the power of 1 is 2 plus 1 times 2 to the power of 2 should be 4. So that should equal 6. So we'll just move our breakpoint down here and then double check that the answer was 6. So the answer was 6. That's good, so we'll just have a few more here. So we'll have 1 right shift to the 1. So I'll literally just copy this whole thing here. Code reuse. So we'll have Telesco said that guy Telesuco, the guy that codes mostly Java Android stuff. Actually, he does a lot of stuff now, but that the guy from India that does that guy has like 1 million subscribers or something, a couple million. His channel is really good if you guys are looking for stuff too, but that's where I learned from when I had some trouble. Anyways, he said code reuse, not copying. So I just remembered that guy's funny. So anyways, we have a right shift 1. So that's what we want here. So we want, instead of a left shift, we want a right shift. So we had a left shift up here. This time we actually want a B right shift 1, so we're going to take B here. So we'll take a B right shift 1. Then here at the end we'll have B right shift 1. That should be correct. B right shift 1. Format specifier and a string B right shift 1. Okay, that's fine. So we have next one here. We want a B right shift 1. We need to grab the binary that we already got here. So we have binary is base 10 right here. Sorry, base 2 in 8-bit representation. We take that one here, just paste that there, and then we're going to want a right shift 1. So instead of moving that left 1, we're going to move that 1 over here. I hate when it does that. We're going to move that 1 space to the left, 1 digit to the, sorry, we're going to move that 1 digit to the right, and everything else is going to move 1 to the right. So basically this whole number is going to be the same thing without the 0. So the answer is 0, 0, 0, 1, 0, 1, 1. Then we tag 1, 0 to the end of the left side. And then we do the conversion back to decimal with the powers again. So we'll go 1 times, excuse me, so the answer is 1 times 2 to the power of 0 plus 1 times 2 to the power of 1 plus 0 times 2 to the power of 2 plus 1 times 2 to the power of 3. I believe that's correct. So we have 1 times 2 to the power of 0 plus 1 times 2 to the power of 1 plus 0 times 2 to the power of 2 plus 1 times 2 to the power of 3. Okay, so that's fine. So here we have 1 plus 2 plus 0 plus 8. I think that's 8. So 1 plus 2 is 3, plus 0 is 3, plus 8 is 11. So the answer should be 11. So we'll just check that here. And the answer is 11. So great job, guys. So we'll just do the last one. So it's going to be a left shift 2, a left shift 2. So we'll just take this here, code reuse again. And then we'll just take a left shift 2. So we'll just change the string to a 2 and then change the variable to a 2 here. And then we'll just copy this whole thing here. Paste that here. Give you guys some more room to see, remove that debugger thing. Debugger panel, whatever. So we'll have a left shift 2. That's gonna be wrong. Okay, so left shift 2. Okay, so this, we're gonna start here this time instead of starting here, because when we started here, we moved this digit left once. So this time we're gonna start here and move this digit left twice. So this is gonna be the same binary string or without 2 zeros. So it's going to be the same binary number without 2 zeros. So we're going to take the first 2 zeros, drop them because we're shifting everything over twice. So this 0 is going to move over here like that. This 0 is going to move over here like that. Then this 0 is going to move over here like that. This 0 is going to move over here like that. This one's going to move over here like that. And this one's going to move over here like that. Then we're going to add 2 zeros to the end. So we're basically just dropping 2 zeros. So the answer is 0, 0, 0, 0, 1, 1, 0, 0. So then we're going to have 2 to the power of 0. So 0 times 2 to the power of 0 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 2 plus 1 times 2 to the power of 3. 0, 1, 2, 3. So 1 times 2 to the power of, 0, 1, 2. So 1 times 2 to the power of 2 plus 1 times 2 to the power of 3. So 1 times 2 to the power of 2, 1 times 2 to the power of 2, 0, 1, 2, 1 times 2 to the power of 2 plus 1 times 2 to the power of 3. Equals to 2 times 2 is 4. So 1 times 2 to the power of 2 is 4 plus 2 to the power of 3 is 8 times 1 should be 8. Answer should be 12. So I'll just double check that. Ended up kind of being a long video, but that's alright. So here we have the answer is 12. That's what we got, right? 12. Yep, so that's the final answer. So hopefully you guys understand. So that was binary. Sorry, that wasn't. Yeah, that was bitwise operators in C programming, bitwise operators. So in the machine code, a lot of this is happening in the back end, so they want you to know what's kind of happening. So that's why we have to do this. We have to work with the binary digits, do the binary math to move the values around. So that's what's happening. That's the point of the lesson, I guess. So hopefully you guys understand. If you guys like the video, you can like and subscribe if you want to support the channel. Thanks for watching, and I'll see you guys next time. Take care.